Hello bachcho, let's read the question. So the question says in figure 29-41, four long straight wires are perpendicular to the page and their cross sections form a square of edge length A is equal to 40 centimeter. The currents are out of page in wires 1 and 4 and into the page in wires 2 and 3, and each wire carries 12 ampere. In unit vector notation, what is the net magnetic field at the square center? So we have to find the net magnetic field at square center. Let us name that point as O. Okay, so now let us first revise the key concept behind this question, on which this question is based. So the key concept behind this question is that the magnetic field at a point away from long straight wires. Okay, so these are long straight wires. So away from long straight wires, which are infinitely long, is given by B is equal to mu naught I upon 2 pi d, where d is the distance of that point from the wire, I is the current flowing in the wire. So keeping this in mind, and another key concept, the direction of magnetic field is given by right hand thumb rule. What does right hand thumb rule say? It says that when we put our thumb in the orientation of current direction in the wire, then the curl of our finger tells us the direction of magnetic field at a point around that wire. So keeping these two concepts in mind, let us find our solution. So for solution part, what do we have? So for solution part, let us say this is point O. Then due to point A, the direction of magnetic field will be in this direction. Okay, so this is in this direction. And let us say it is 1, or say B1. Okay, and due to 4, it is in this direction. It will be equal to B4. And similarly due to B2, now B2 is going inside the plane, and hence it will be in this direction by right hand thumb rule. So B2 will add along with B4 and B3 will add along with B1 similarly. So these are the final net magnetic field, and their constituents will come in this direction. Okay, so now let us find it in vector unit notation. So let us find all the values b1, b2, b3 and b4. So b1 will be equal to mu naught I upon 2 pi d. Mu naught I is given to us as 12 ampere upon 2 pi into d is given to us as 40 centimeter. Sorry, A is given to us as 40 centimeter. Now we have to find the distance between 1. So we are finding B1. So we have to find B1. So this distance we have to find, the distance between 1 and O. So this distance can be found out by Pythagoras theorem, as this is A by 2 and this side will be A by 2. So let us find D is equal to square root of A square by 4 plus A square by 4. It will be equal to square root of A comes out common, and square root of 1 by 2, it will be equal to A by root 2. Okay, so A is given to us as 40 centimeter. So the distance will be 40 centimeter into 10 to the power minus 2. It converts into meters, and our root 2 goes in numerator. So we can solve it. We will get 2 into 10 to the power minus 7. Mu naught upon 2 pi is 2 into 10 to the power minus 7. And it solves to become 12. 3 root 2, sorry, it will be in multiplication. into 3 root 2 into 10 to the power 1. So this is the final value and it will become 6 root 2 into 10 to the power minus 6. This will be in Tesla. So this is the value of B1. Similarly, we can find B2, B3 and B4 as their distance from the point is same and their currents are same. All of their expression will be same. So B2 will be equal to B3, will be equal to B4, will be equal to B1, will be equal to 6 root 2 into 10 to the power minus 6 Tesla, and the only thing that matters in this case is their orientation. Okay, so as I have shown you in this figure, the orientation will be like this, and hence the net magnetic field will become something like this. This will be equal to 2 into what we are given. So it will be equal to 12 root 2 into 10 to the power root minus 6. So it will be 12 root 2 into 10 to the power minus 6 Tesla in this direction. And it will be 10 root 12 root 2, sorry. It will be equal to 12 root 2 into 10 to the power minus 6 Tesla in this direction, and their resultant will be something in this direction, and it will be correct perpendicularly between them. Sorry, it will be correct between them, and these two directions will be perpendicular to each other, and hence at their 45-degree. So we can write the final B will be equal to 0 I cap, because there will be no B in X direction, and plus what will it be in this direction? It will be equal to square root of what we have found out, 2 into 12 root 2 into 10 to the power minus 6 whole square. Okay, so it what does it comes out to be? It comes out to be equal to square root of 4 into 144 into 10 to the power minus 12, and it is nothing but 24 into 10 to the power minus 6. This much j cap, this much j cap, and hence we can write the value of B is equal to 0 I cap plus 24 into 10 to the power minus 6 j cap, this much Tesla. So this is the final answer of our solution. I hope you understood it well. Thank you.